Understand the thermodynamic criterion for favorability. A chemical reaction is thermodynamically favored, spontaneous, under standard conditions when its standard Gibbs free energy change is negative, delta G degrees, less than 0. Recall the Gibbs-Helmholtz equation, the relationship between Gibbs free energy, delta G degrees, enthalpy, delta H degrees, entropy, delta S degrees, and absolute temperature, T, in Kelvin, is given by delta G degrees equals delta H degrees, T delta S degrees. Analyze the signs of the thermodynamic parameters from the table. Looking at the data provided on page 25 of the exam booklet. Enthalpy change, delta H degrees 298 plus 12 kilojoules per mole of reaction, positive, meaning the reaction is endothermic. Entropy change, delta S degrees 298 minus 10 J/K moles Rxn, negative, meaning the system becomes more ordered. Evaluate the sign of delta G degrees at any temperature, T greater than 0 Kelvin. Substitute the signs of delta H degrees, plus, and delta S degrees, into the Gibbs-Helmholtz equation. Delta G degrees equals, plus, T, delta G degrees equals, plus T, plus. Since absolute temperature T in Kelvin must always be positive, the term T delta S degrees is always positive. Adding two positive values, delta H degrees and T delta S degrees, will always yield a positive standard Gibbs free energy change, delta G degrees greater than 0. Conclude, because delta G degrees is positive at all temperatures, the reaction is not thermodynamically favored at any temperature, confirming option D as the correct answer. The correct answer is option D. It is not favored at any temperature.